So for this problem, we have 2-point charges, 3q and negative q, which are separated by a distance a. For each of the arrangements, we want to find either, one, the monopole moment, 2, the dipole moment, and 3, the approximate potential in spherical coordinates at large r, which include both the monopole and dipole contributions. So for the first one, let's see if I can try to split the screen. So for I, or for A, I'm sorry. First, we want to find the monopole moment, which should be, since that negative q is at the origin, it just be the addition of, well, since they're on the same axis, I'm saying axis, I'm sorry, yeah. It would just be the addition of those two. So our monopole moment would just be 2q. The whole math. So it would be that 3q minus q. So it would just be equal to 2q. Our dipole moment would be 3qa z hat plus negative q 0 b equals 3qa z hat. And now we want to find the monopole moment. We want to find the expression for the total potential of the distance, including the monopole term. So we have V of R is equal to V Q and Q plus V dipole. So that's just 1 over 4 pi epsilon naught Q over R plus 1 over 4 pi epsilon naught P R over R squared, which is just equal to 1 over 4 pi epsilon naught 2q over R plus 3qa cosine theta all over R squared. And we know that R is equal to 3qa cosine theta. So our final answer is 1 over 4 pi epsilon naught 2q over R plus 3qa cosine theta over R squared. You just want to repeat the same steps for B. So again, we got two charges, same axis, z axis. So you have my monopole moment is just going to be at 3q minus q. So then that would just equal 2q. For our dipole moment, it would be P be equal to negative QA in a negative z hat direction, which is just QA z hat. Now, find the total potential again. So VR plus V monopole moment plus V dipole. which is just equal to 1 over 4 pi epsilon naught q over r plus 1 over 4 pi epsilon naught p r over r squared. I'm going to plug in 2q, our 2q that we got for our monopole moment, and the 3qa we got 3qa cosine for our PR. So it'll be V of R is equal to 1 over 4 pi epsilon naught times 2q over R plus 3qa cosine theta over R. And that would be, over R squared, I'm sorry. And that would be our total potential at a distance R, including the monopole term. For that one. And then last, repeat the same steps for part C. So again, our monopole moment will just be the addition of those two because they are on the same axis. Which equals 2q. Our dipole moment will be simply 3qa y hat. Of course, is monopole. Total potential is monopole plus our dipole. So we get 1 over 4 pi epsilon naught q over r plus 1 over 4 pi epsilon naught p r over r squared, which is just equal to 1 over 4 pi epsilon naught 2q over r plus 3qa sine theta sine phi over r squared. Therefore, the total potential at a distance r, including the monopole moment, is this final answer here. Thank you for watching this question.